Blocking assignment in synthesis. As discussed in previous slide, this always block produces 2D flip-flops and you need to make connection now. Both statements are written in the same always block and blocking assignment are used. Thus the circuit should behave in an equivalent manner of executing these statements sequentially. Therefore, the output of first flip-flop will be connected to the input of next one using the wire B, as shown here. Now, as seen in case of synthesis, let's reorder the statements in the always block and see the effect in the circuit produced. First B will be assigned with value of A, and immediately, C will be assigned with value of B in the same clock, because the statements are using blocking assignments. In order to produce an equivalent circuit, you need to connect the input A to both of the flip-flop, as shown here. When A is connected to both, in the same clock, both B and C will latch the value of A. From these description, it is clear that the order of the expression within an always block is controlling the final output behavior of the circuit connections. Non-blocking assignment in synthesis. Now you will see the circuits produced by the same examples from the previous slide if they are using non-blocking assignments instead of blocking. As discussed in previous slide, this always block produces 2D flip-flops and you need to make connection now. Both statements are written in the same always block and non-blocking assignment are used. For NBA, all LHS expressions will be evaluated using their values from the previous time slot, and at the end of current time slot, all of them will be assigned to RHS variables simultaneously. In both of these always block event, though the order of statements are different, C will be assigned with previous value of B, and B with previous value of A. Thus it will produce the circuit shown here where A is stored to B and B is stored to C. If the order of statements are changed, it will not make any difference in the final circuit, because all variable are updating the values from the previous time slot. From these description it is clear that, in case of non-blocking assignments, the order of the expression within an always block is not controlling the final behavior of the circuit.